that right? It's not right.
Order of operation.
So what's the answer?
110.
120? Well, all right. That's going to be the next test. All right, so while we're trying to get some, I want to type some code at some point, so there's going to be a problem with that. But, all right, we've seen try catch, right? And for example, we had try equals a new scanner on a file, and if that failed, we did a catch of some exception, file not found. Oh, we're going to get in the wrong way here. Exception E, and we did something at that point, you know, like tried again or died or whatever we wanted to, right? So we've been looking at this try catch as a mechanism for handling errors. And it's much more integrated into Java than many other places. A lot of other languages still sort of encourage, sometimes want you to return some like -1 value if you don't find it, or return null, or do something like in the returning from the method. But Java really likes you to get these exceptions happening. Now, where do these exceptions come from? And what are they? So first of all, if you see something, file not found exception space E, what is E? What kind of thing is E?
Isn't it a variable?
It's a variable, yeah. Okay, so what kind of, in Java there's sort of two kinds of variables.
And it's
Is it a primitive or an object, I guess?
Object.
It's an object, right? Some kind of object. So one question is, where did this thing come from? And the answer Ashkan is like blocking half the board here, but I'll help you
He's
over
the
here.
star of the live stream right now.
Basically, in code, you can throw your own exceptions. So somewhere in code, I can say throw, which is a Java keyword statement, a new file not found exception So this is something that means throw for something to catch. What is this part here doing? Yeah, it is making a new object of file not found exception type, and this is a constructor for it. Okay? So we're constructing a new exception. This throw mechanism is sort of mysterious, but basically it says, hey, I have one of these, can anyone catch me? And looks around the code to see, who should catch it. And if someone finds it, it passes this object to the catch, and E now references this object. Okay, so there's nothing too mysterious in some ways. It's sort of an awkward way of passing parameters in some sense to the catch thing, but we're making an object, and that gets sent to the catch.
So is file not found exception, is that a class or is that an object that we created?
So this is a type, so it's a class. If you make a new one of those, it makes an object, right? So this part is the type, and it wasn't really the constructor, but it matches up with the name of the type. And then this whole part makes the object.
So where does E fall in this whole scheme? Is it a sort of parent class?
So when we have catch file E, this object is passed to E, and this references that object. Okay, so it's basically another parameter kind of passing thing, but rather than seeing, I call this method and I pass it and I cut, and I receive it here. It's the connection between these is a little more tenuous. It's like, what's happening? Sorry. Back to HTML.
We need the splitter though.
Put that in there. All right. Wow, that's a whole team here.
Now remember this when you're nominating best teammates.
Happy. All right, so we have an opportunity in our own code to generate our own exceptions, and we're going to be doing that a little bit in the next assignment. But this is where I'd like to write some code, and so I'll just hold on for one more second here. So what do we have going on here? We have the VGA.
It's not going to work connecting.
I think just do the camera and pick
Yeah,
up the
just do the
VGA.
camera.
Yeah. Still not liking me? It's a resolution, I think. Hold on. VGA can only handle like
I broke the VGA. There goes my nomination.
let me set it to a real.
There.
Oh, there we go. Okay. All right. We'll seamlessly transition to a low-res. Oops. All right, so and I'm going to turn off the center projector here. All right, now we've got a crank here. All right, so, so let's say we have a class called pick one or two. And in this class, we're going to hold two values, and we're going to let the person pick either the first value or the second value. So in this class, we want to hold two things, and so we need some instance variables, right? And so let's make a private int 1 and a private int 2. So every time we make an object of this class, right, we're going to have its own storage for 1 and 2. And then I need a constructor. Pick 1 or 2. And it's going to take in two values. Yeah. Int 1, int 2. And in here, I'm going to initialize those instance variables to be set to those values. Now notice, again, I made my parameters be the same name as the instance variables, so I need to disambiguate that by using this. So when I say this one, that's the instance variable, equals to 1, and this one is the locally scoped parameter, right? And this 2 equals 2. And again, we had that discussion, like, should we really do this? Is this a bad idea? I can't say whether it's good or bad, really. I should have said starting 1, starting 2, not have a conflict to begin with, but I decided I wanted to go for this mechanism. Any questions first of all about that? Because, we've done that a little bit, but you should be seeing what's going on here. Yeah.
So the one with this dot is the private, or the instance variable?
This is the instance variable
Okay.
that refers to this thing here, the storing object. This one doesn't have a qualifier, so it looks for the most innermost place where it's defined, which is here, and picks the parameter. Kind of weird, right? Yeah. All right, so let's do something that lets you pick something. So I want to pick one of those, and I'm going to send in my pick. And in here, it's going to be if pick equals 1. I'm going to return 1. Now, which one is this? There's only one possibility in this case. There's no local 1, so it's going to be the instance variable 1 here, right? Now, I would say if this were a more formal piece of code, you should probably have some consistency there. And I don't really like having this 1 mean the instance variable and here 1 meaning the instance variable, so maybe I would decide to do that anyway, just so it's consistent throughout my code, right? But again, that's a choice someone's going to be making about that. Else, if pick equals 2, return this dot 2. And okay, let's try this out. That's enough to at least get started with this. I have some extra things here.
Do you want to more return? Because it can.
It's going to complain. Yeah, it's going to. Well, okay. Yeah, it could be something else, right? I'm just going to do that for now, just to make it be quiet for me. Okay. Okay. So let's make one of these objects. So I'm going to make an object of pick 1 or 2 type, and I'm going to call it P for pick, and I'm going to make a new pick 1 or 2 object, passing in 1 and 2. So at this point, P is an object on the heap. It holds a 1 in its 1 instance and a 2 in its 2 instance, and this P variable references that object. And I could say, system out, let's print out a choice. And so I could say P, make pick, make pick 1. And if I run this, I get a 1, yeah. And there's another possibility, right? I'm going to make pick of 2. And I run it. And I get the 2. Yay, so everything's good, right? Is there anything else I could do? Oh, 3, right? And in this case, gives a -1. Now that's a value. If I wasn't paying attention, I would maybe think that's the value stored in the 3rd location or something like that. So that's a little dangerous. And so instead, we want to somehow generate an exception saying, hey, we're not allowed to pick anything besides 1 or 2. So I can have an else here, and I can return or I don't want to return, I want to throw a new. Now the question is, what kind of exception should I throw here? We don't want to throw a file not found exception, right? Like that would be, it would cause a problem, but no one should be looking for a file not found exception from this method, and so it's likely it won't be caught. You only catch particular kinds of exceptions, right? So what's another possibility that you might have run into? Index, yeah. Index out of bounds exception. I already know it's exception. I hate having to tag the word exception at the end there. But so I'm just going to throw a new index out of bounds exception, and when I run it, now I got an exception. It seems like a bad thing, right? Like now it's crashing rather than returning -1. So what could I do down here to make things better? I could do a try catch and catch that index out of bounds exception kind of thing, and then say, naughty, naughty, don't ask for 3 or something like that, right? So that would fix it and make the user feel real good about themselves. Okay, so that's the mechanism here. We have the power to make our own, use these exceptions. Later we'll see how we can actually make our own custom exceptions that aren't part of the built-in Java set. So there's a whole bunch of built-in ones. There's an arithmetic exception for like divide by 0. There's something called an argument exception. Then I maybe should have used an argument exception here, where basically someone passes in a kind of argument value that's not allowable. Anyway, there's about 30 or 40 built-in exceptions that you could use if you want to, but at some point we'll learn how to make our own as well. You can also add a message in here saying, you should pick 3 or something like that, and that would get reported as the message when you catch that exception. So anyway, nothing too crazy, but basically we use this throw, and then we generate a new object, a new exception object of some type, and then the catch can catch that exception. Okay, so it's just one new little bit of syntax here to make this happen. All right. More clickbaity version of this there. Got you anyway, so I'm happy. So anyway, here's some same code. Now, we should talk a little more about exceptions. There's 2 kinds of exceptions. You might have run into this if you're kind of Googling around trying to learn about exceptions a little bit. There's something called checked exceptions, and those are the ones that happen based on the user or some external factor doing something that doesn't work for you. So it's not like the code logic is wrong, but like they type in a file name that doesn't exist. And so in general, those are considered to be recoverable because if they type in a bad file name, you can ask for another file name, right? So there's a way to make that get fixed. Checked exceptions have to be handled. So that's the one when we had those, calling something that would possibly throw a checked exception, Eclipse would complain and say, you're not handling this checked exception, what do you want to do? And it would like try to wrap stuff in a try catch for you and all that kind of stuff. So checked exceptions need something to make them be safe. Unchecked exceptions are things that happen based on bad code or logic. So an index out of bounds really is, you sort of feel like back in my code, the user was asking for the third item, but really it was the code asking for the third item, right? And you should never be asking for an index that doesn't exist. We know how long arrays are, and so there's no reason to ever be saying, give me array index 1,000,000 when it's only 5 long. And so you should have other code in there that protects against that kind of thing. And if you are asking for it, it's a sign that something has gone wrong with your code. And in general, the reason they don't force you to catch those is that there's not much you can do about it. If things are so wrong, awry, you're asking for an index at -5 or something like that, then it's just time to give up, right? So if you catch it, it's just to die gracefully and not have that stack trace spat out at you. Now these checked exceptions, there's two ways, and again, Eclipse kind of has hinted at it, and we only looked at one. So you can wrap a try-catch block around the code that causes the exception, and that's what we've been doing. But the other way is basically pass responsibility at the call stack by adding a throws clause to your method. So this is kind of a strange thing, but here I could have public int, read int, I'm going to get some file. Presumably, I'm going to try to open up that file and use it somewhere. And so there's a chance that something in here is going to throw a file not found exception. And again, I could wrap that in a try catch, but it's possible that this method here is buried deep in some big program, and I want to maybe get a message back to the user, but I don't have any access to like the GUI or something like that deep down in this class, and so there's no way for me to really get back, break up to the windowing system and make an appropriate kind of message. So instead, I can add this throws file not found exception and make it the responsibility of whoever called me, whoever called readInt, to handle that. Now they could also pass it up with their own throws statement and say throws file not found exception, and eventually it would trickle its way up until some method does catch it and can put up a message, on the window saying this file is not found, please try again. So there's ways to kind of defer responsibility. Now what this does means that you don't need a try catch in here, but calling this method becomes a checked exception kind of method, and whoever calls me either has to wrap that call in the try catch or have a throw file not found exception or throws on their method. Okay, so you either have to make sure explicitly defer responsibility for a checked exception, or you need to actually handle it with a try catch. But at some point in that chain, someone's going to have to do a try catch. It could be it could be a main somewhere or something like that, but you got to handle it at some point. Okay, so questions on that? Okay, so this mechanism to me seems always a little foreign because we're used to evaluating code. You go through it line by line and you sort of see what happens, and all of a sudden there's this mechanism to make big jumps happen, and you kind of lose your focus of where the execution is, and so you have to kind of think about it a little bit differently.
So it's going to run through the whatever's in that method right there, and then if it ever throws the file not found exception, then this will get passed up the sort of the chain of command.
Well, this is actually a compile time mechanism. So the checked exception really happens at compile time. It says, is something handling something that could throw this checked exception? And if it doesn't find it, it'll complain and force you to handle it before it will actually run, right? When it runs, then it just actually throws it, and anytime there's a throw, it just goes back up the call stack and figures out who's the nearest catch. So it's the same mechanism at that point as an unchecked exception. Like if I have something that causes a null exception, I can catch it way up the call stack, and that's fine, but it's not enforced. Okay, one more thing that sort of hinted at, but I need to just sort of mention for the assignment a little bit. So we've seen overloaded constructors. So in constructor, I could have I can't remember what we've been constructing, like myval or something like that. And it could take no values, and then that constructor could generate a default value inside it. But I could have another constructor that has something that takes a value in, and it assigns that value to the instance values. And so anyway, I can have multiple constructors, but similarly, I can have multiple methods with the same name. So it seems a little weird. So here I have a method add that takes in 2 ints, and in there, presumably, I'm adding them together or something like that. So this is, again, part of a class, right? So it's a method of a class. Now I can have another method called add that takes in 3 values, and presumably, it adds those 3 values together. Now, before you were allowed to overload methods, you might have some nomenclature here, add 2 nums, add 3 nums, add 4 nums, whatever you wanted, you know. And that's fine, people could figure it out. But it's sort of nice to be consistent and just have a method add, and if you put in 3 numbers, it adds those 3 numbers. If you put in 2 numbers, it adds those 2 numbers, right? So it's sort of a way to ease the burden of working in a big code base by keeping the names kind of the same. Now here, I have two parameters. Here I have 3 parameters. Here I have 2 parameters, but they're different type. And the compiler is smart enough to recognize that that is a different thing. Adding 2 doubles is different than adding 2 ints. And so you're allowed to overload a method both with different numbers of parameters and also different types. Okay, so I could add 2 strings, I could add whatever you want there. Yeah.
Can you make kind of a dynamic?
Yeah, there's sort of a funny way you can make, so you can have any number of arguments sent to some kind of thing. Yeah, and we'll probably see that at some point. Okay, so this is really just sort of a little bit of like not totally necessary, but practice has shown it's sort of nice to have this option.
So with the overload with the double parameters, would that return a double?
Oh well, actually here I didn't really update that. It's okay if I want to return an int, that's allowable. I can have the same. So a difference in the return type doesn't make the overload different. You need to have a different in the parameter type. In this case, probably if I'm adding 2 doubles, I should make that a double there. I just didn't cut the base properly. Okay. But either one would work. All right. All right, so let's talk about arrays for a second. What's the big problem with Java arrays?
Shallow copy.
Well, shallow copy, that's not a problem. That's the way it should work, right? No. Because anytime you're talking about objects, it's a shallow copy. The parameter of an object is a shallow copy. It's actually a benefit because you can change what's inside without it being a problem. So I know it's a problem, so it's hard to debug, but you're going to say something. Yeah?
It's not to add a number in the middle.
So you want to add a number in the middle without overwriting what's in there. You want to insert something, right? Mm-hmm. And not just the middle, but it's hard to add a number anywhere, right? And if you're adding a number, what does that really mean you're doing to the array? It's expanding it, right? We want something where we don't have a fixed size array. It's super annoying. Let's say I have a loop and I'm asking you for everyone you want to invite to a party. And in the code we have so far, I'd have to say, I'm going to make an array of 4 names, and that's all you get, right? But with an array that expands, you could type as many friends as you want to, and then hit return empty string to end it, and I could capture all 230 of those names that you're going to invite to your big party, right? So we would love to have arrays that can expand in size. Now that seems like a tricky thing, but it's actually not so bad. So we're going to call this a dynamic array, and basically if we want to have new values, we're going to expand the array, and the general approach is we're going to make a new array that's bigger, big enough to hold the new values, and then we're going to copy all the old values over into the new array, and then add whatever new values we want to add to the end, right? So we had one array of a certain size. So we had an array with, 3 spots, some values in it. I wanted to add the 4th value. There's no spot for it. I'm going to generate, I know how long this array is, right? You can ask its length. It's 3. So I'm going to generate a new array of this length plus 1 and get 4 spots. And then I copy down these values. And then I have room for this 4th one to go in there, right? And then I want to add another one and I do that process again. Now it seems a little crazy because it's not like instantly cheap to make a new array, copy all the values over, but we can make an expanding array this way. Now, if we did this approach, where again we have some array we're keeping track of, and then how long it is, and if something gets added, we make a bigger one. We have to think about sort of how expensive is this to do. So, let's say I wanted to get an element out of this array. How expensive is that? How many elements? If I said, give me the element index 1, how many elements do I have to look at to get that? 1. Okay? The compiler's smart enough. It doesn't have to start at the beginning and count up 0, 1, 2, 3, 4, 5, 6 till it gets to 6, right? It says, okay, these all take a certain amount of memory, space in memory, and if I want the 6th one, move forward that many spaces in memory and get right to it. So, like right away, you can get to it. If I wanted to change a value, how expensive is that? It's 1. It says, okay, same thing. Find that spot in memory and change that value. You're not looking at other elements. How about when we want to add an element? How expensive is that? Well, there's a process. We don't really know how expensive it is to make this new array. We're going to say that sort of takes one chunk of time, right? But there's this process here where we're looking at every element and copying it over. And so the expense in this case of adding one is the length of the array, basically, because we have to copy things over. And in our big O notation, the get element is cost 1, so we jump right to it. Set elements cost 1, but the add element is sort of expensive. And so you want to be a little cautious about that. That doesn't seem that bad. Oh, we have 100 things. But again, in computer science, we're starting to start talking about things that are, you know, 1 million items or 1 billion items. And all of a sudden, looking at 1 billion things to copy them over gets sort of expensive. So let's code this up. All right, so it seems, you know, a little implausible almost. You're like, we can't just like make a dynamic array, but we can. So private, I'm going to have this array hold strings for us, okay? So inside this dynamic array, encapsulated in it is going to be this other Java array of a fixed size that holds strings for us. So it's going to be of type, string array, and I'm going to just call it data. So the data we're holding is an array of strings, and if I want to construct one of these things, I always have trouble remembering my little public things. If I want to construct one, we're going to make one start off be an array of a new string array of size 0, basically an empty array. So if we have an array that can grow, we don't have to set its size 10 to begin with. We can just say start off empty, and if we add things, then we can just grow to handle that. All right, so if I were to make a dynamic array object right now, inside it, hidden from us, is a string array that holds nothing right now. And so let's add some ways to access this protected data array so we can get values in and out of it, our setting and getting of values. So I'm going to have a get element, and it's going to be at some index. And basically, I'm going to return data at index. So this seems, a little useless. Basically, we had a perfectly good array here that we had nice notation to get a value out of, and now I'm wrapping it all in this other class. Wrapping in this other class that, and actually I have to return a string type here, that has its own notation, get element, okay? But I pass in an index, and it returns some value here. What's something dangerous about this method right now? What could you do that would break things? Yeah, I could pass in a bad index, right? So I'm going to say if index is less than or equal to less than 0, yeah, less than 0, 0 is legal, or index is greater or equal to the data.length. So valid indices for an array are from 0 to its length minus 1, right? That's length elements. And so if I go below 0, or I pick an index that's equal to the length, not -1, but equal to the length or greater, then I want to throw a new index out of bounds exception constructed like that. All right, so I have a little code here that I want to be certain that I'm going to throw an index out of bounds. Now, in this case, actually, I will say it's a little redundant. This thing would throw an index out of bounds exception for me, but we'll see later why I want to have my own index bounds so I can be a little more clever about what's going on here. Okay, and I wanted to show you how we do that. All right, yeah.
When you throw an exception, it automatically jumps out of that method? It's basically
It looks for something to catch it. If there's nothing to catch it, it just dies with an exception error.
Yeah,
And if it does catch it, then it jumps to that location.
but it won't automatically just go down.
It doesn't go somewhere, yeah. Whoever called this method would have to have the try catch to catch it. Or whoever called that method would have to try catch. All right, so let's be able to set a element at an index. And I'm going to pass in a string with a new value as well. So to set the element, we need to know where to set it, and we need to know what value to set it to. And I'm going to steal some of this code. It's almost the same, except instead of returning data index, okay, we're going to set that to new value. All right, so I pass in where I want to set it, and I give the new string, and I set that internal data to be like that. So this is now nothing besides a fixed size array that has its own set and get methods. We haven't expanded it yet. It's the expanding part that gets interesting, right? So let's try to make this thing, let's make this thing expanding. So I'm going to have a public void add, and I want to say where we're adding it to. I'm going to use I here. And I want to say what I want to add to it. So the meaning of this is if I were to say, if I have my dynamic array object and I say add at 1 high, then this is index 0, this is index 1, this is index 2. I'm saying I want to take this and shove it to the right, make a space, and put that value in there. So I need to go back to strings here, I guess, because we're working with string element types. And I will make them very simple strings. So if we had an array like this is data, our data array. We want to somehow, and we say add 1, this location here. This would be the same. I want to shove these over, so I want to shove them all up by 1. Make space for the new item. I've expanded the array as well, right? So I added 1 to the length, and then I copied this one here, and this one here, and then I want to actually insert my new string high in the middle there, right? So that's what it means to grow your array. We're going to make a new, bigger array, copy all the values, shove them over where they need to go, and we're good. Let's say I said now, so added index 4. Should I let this happen? I don't have an index 4. You want to die? All right, so I have these strings here in indices 0, 1, 2, 3, and I want to say add at location 4 in E. Should I let that happen? Yeah, I want to be able to add to the end of this array. I want to be able to grow it by adding to the end, right? So I want 4 to be legal here, and I would then make a new array with 1, 2, 3, 4, 5 spots. copy these all down. And then add E on the end. So if you have a growing array, a very common thing is just sort of keep adding something new on the end. You know, you get names, you want to keep adding them. Yeah.
What if that were 5E instead of 4?
Well, you can decide. Some languages want dynamic arrays to expand to the size it should be. Java tends to say no, that's not allowed. All right, you can only add one to the end. So, and we'll stick to that meaning. Okay, so let's write our add code. So the steps are make a new array that's bigger and copy stuff over where it needs to go. Okay, so let's make a new array. A string new data, and that's going to be a new string array of what size? Data length plus 1. Yeah, we want to add 1 to the length, basically, right? Why are you complaining?
You need array, you need brackets after string.
String array new data. All right, so we're making a new one. And now, there's 2 steps to the copying process. We want to copy straight down all the things to the left of index, and then copy 1 over all the things to the right of index. Okay, so we will, for int, what do I call it here? Here I call it index, like a good person, instead of before. Index 0. Index less than how far should it go? I. That's the one we want to change, right? So we want to go up to it but not include it. And then index plus plus. And all I got to say is new data at index equals the old data at index. Right? We're doing a straight down copy. 0 to 0, 1 to 1, 2 to 2, until we hit index. All right, so copied, this code, we've copied the left of the index. Now we want to copy the middle, or copy the index location over. And so new data at I equals the new string we want, right? And then we want to copy, push over stuff to the right. So here, I want to go from, for int index equals I plus 1, and index less than the new data length, because we're going to go up to the end of our new data, and index plus plus, index plus plus. I want to take new data at index. In other words, I want to take this location and copy it from that location. What is that location? I'm going back 1 to get to this one, right? So I'm here at 2, and I want to copy it from 1. So it's going to be at data at index minus 1. Yeah, I think that's right. Okay, so that's, where am I on this thing? Oh, it's already indented, that's why I was confused. And so now new data is filled with all this stuff, and I want to say that data equals new data. All right, I want to just make this now be stored in the object's instance variable. So I sort of had some temporary stuff, I messed around with it, and then I want to throw away the old one and make the new one be the official kind of one. All right, so let's make a, we're never going to get, I need to write a print statement to get to this thing, unfortunately. Okay, let's make a dynamic array D equals new dynamic array. And I want want to say d.add at 0. There is nothing in there right now. And let's do a system out and see if it's in there, I guess. System out d.get 0. So if I run this, we think it's in there. And if I did a d.add 0 Joe, and then looked at both those locations, 0 and 1, what should we see at this point? I'm going to get rid of this one, I guess. I don't need this anymore. So I added David and I added Joe. And when I print them out, starting at 0 and then 1, what should I see? All right, you're all mumbled enough for me to believe you, yes. So we kept sticking it at 0, right? So we first put in David, and then we shoved it over and put Joe in there first. So we're going to see Joe at 0 and David at 1. And that's what we have, okay? Okay, now, really quickly, this is expensive. If I keep adding, I'm like copying this whole array each time. We don't like that, so there's got to be a better way. So we need a different growth strategy. A different growth strategy is when we add something, let's add some extra spaces, and then the next time we want to add something, we don't have to make the new array. Maybe you don't even have to copy the whole thing. Okay, so we're going to add like 5 spaces instead of 1. So if we have a big array, and we're going to say the array we're allowed to use is size 2, we're going to call that the virtual array size. Then we want to add something. Let's say we had 2 items in there. We want to add another item. Then we just grow the virtual array size. We don't have to copy anything more. We don't have to make a new array or copy it. We just say, hey, the array is going to use a little more of this thing called the backing store, the big array that we're kind of slowly filling up. Eventually, we're going to fill it all up. And in that case, then, we do have to make a new array that's bigger and copy stuff over. But that doesn't happen every time we add it, and that's the important thing. So we can add stuff like to the end, for example, cheaply while there's extra spaces in this larger backing store. But we're going to pretend the actual array is smaller, all right? So for your assignment, I'm giving you this dynamic array that makes a new array every time we add a space, and it's sort of inefficient. And I'm going to ask you to write one that instead that doubles the size of this backing store and grows the virtual array inside it 1 by 1 until you need more space, then doubles again, and doubles again, and doubles again. And then I have some code to do a speed test, so you can see how much faster it is to do it that way. All right? So you want to look at the dynamic array code that's part of the project, part of the assignment. When you download it, there's a fully implemented dynamic array. See how it works for sure, and then work on changing it for the assignment. And there's another thing you got to write as well.